Hello everyone, I'm Artikosa. Our focus now is on completely randomized design. So we're going to focus on both balanced and unbalanced, how to construct the ANOVA table, considering the model where ij is mu plus ti plus ei, where mu is the grand mean, ti is the effect of the treatment, and ei is the errors. So how to construct the ANOVA table? Let's just put our focus on this given a table where we consider our rows as representing treatments and our columns representing replication. So now our I will range from 1 to T and our J will range from 1 to Ri. So can we discuss about this concept? I want you to have a clear understanding or vision of what's going on in this actual chapter of design and analysis of experiment. So let's construct the ANOVA table, but right now my focus is mostly interested on how these formulas interact and for you to know which formula to use if given the data to get easy the answer. So let me just give you the formula that works for both balanced and unbalanced. Hopefully you understand. So we can start. Let me just try to... Okay guys, we can proceed. I'm about to share with you these most interesting concepts. So can you pay your attention attentively and open your... Yes. So in this case, we are about to understand these formulas. I'm about to make you understand and you won't have a problem. Given any data, you can construct the ANOVA. Recall your SSTO is the double summation Yij square minus the overall sum square over n. Remember previously x bar is the same as the summation of x over n. So where we can make this summation of x the subject, so it becomes n x bar. So relating this to this, so since this one y dot dot, it means we're summing every observation in that given data table. So it will be the same as n multiplied by its grand mean. So because in this case, for us to find the grand mean, we have to take, you can see here, y dot dot we divide by the total number of observations. N is the total number of observations. So this formula caters both balanced and unbalanced. So proceeding further, since this is the case, we can write SSTO in this form. It means if we are given the means and the grand mean, there is no need for us to calculate the total sum. We can use this formula, and even for the treatment it also works. So as you know, is the sum from I to T of this sum of each treatment squared over R, the R of each treatment. So this replication is for each treatment. The reason I wrote Ri, this will be R if it is balanced, because in this case R1, R2 until RT will be equivalent to R. But if it's not balanced, it will be same as R1, R2, R3, where they are not equal. So this minus the overall mean square, overall sum square, all divided by n. So which means using that procedure, given the grand mean and the mean per each treatment, you can use this formula. There is no need for you to find this y1, yi dot for each treatment or y bar dot for each treatment. Will be wasting your time. You can just use this formula and find your SS treatment. So proceeding further, you can see how this formula is being erased. So is equivalent to this. So where this part here, we call it as our tie-eyed. had estimated TI for the treatment. And don't forget this guy, the summation of this is equals to 0. So if they give you type 5 treatments, for example, they give you only type 1, type 2, type 3, type 4, they don't give you type 5. You have to add them, you equate to 0, you find type 5. So that's how it works. So you can come back and use this formula, where you can write it as summation from I equals to 1 to TR type I all squared. So you understand that one is very much easy. So proceeding further, to find our SSE, we are going to say SSTO minus SST, where SSTO is the total sum of square, where this SST is the SS treatment and SS error. So sum of square of the error, sum of square of the treatment, as you know. So our I ranges the double summation, then yi j all square minus the summation I equals to 1 to t of ri, y bar I dot all square. So the reason this is equivalent to this, if you can subtract this part minus this part, you can see what's going on. This part is going to cancel out, it's common. Or it's on this part of n, the grand mean square, it's on both the overall SS square, sum of square, and also the SST. So our SST, that's why is this. So where this it is the same or equivalent to this. So where this guy SI squared represents the variance per treatment. So the guy SI squared is given by this formula, it's here. SI squared is given by summation from j equals to 1 to ri. For which means here, for you to understand this thing, look here. For S1 square is j equals to 1 to r1, then y1j square. So as you can see, everything is squared here. You must understand. For this, then multiply by r1 and y1 dot bar all square divided by r1 minus 1. So in a symbolic way, we can say until since we know that our treatments are T treatments, so ST is given by j equals to 1 to RT, so YTJ square, as you can see here, minus RT Y bar dot T all square divided by RT minus 1. So as you can see, so that's why this formula is very much important. So you must get used to this, because if you are not, you will struggle sometimes, and especially when you are given the errors, you are asked to find SSE. There's no way you find SS total. The only thing which you can find given the errors is our SSE. And our SS treatment, usually in the cases when they give us the errors, they can give us the mean per treatment. So we can use this formula above to find the SST. So to find SSTO in an easy way, you just add these two. That's how we find the SSTO. So proceeding further with this formula, as I said, is important. As I indicated, we are going to, it's done this way. This is how it's done. And this is per treatment. So this part, this guy here is the square of error for treatment number 1. So we square the sum of square of error for treatment number 1. That's why I wrote j from 1 to r1 of E1 j square. So same thing here, sum of square of error for treatment number 2, sum of square of error for treatment number 3, and for T treatment. So this one, as I said, this is the same as the summation from I equals to 1 actually is this guy here. You can see him. I indicated him here. Summation from j equals to 1 to t of etj squared for t treatment. So here, when we sum the sum of square of error per each treatment, all of them, that will give us the total sum of square, which is actually SSE. So you see how these two correlate. So which means for you to find the variance given the errors, you can use this formula here. Since we know that this part is nothing but this one. So for us to make ST the subject, that's why I said variance of T, where T ranges from 1 until those number of treatment, any T, so is given by square. So that's how we do it. So that's why I said we can find until for that particular R. So not to confuse, the reason I used, you have to understand. So this ranges until here I should have written RT, not just T. J ranges from I equals to 1 to RT. Hopefully you understand. So this is how these formulas work. So you'll understand. You just have to be patient with these things, so not to confuse yourself. So proceeding further, I want to clarify most of you because are confused when it comes to the grand mean. So for you to find the grand mean, you don't say the grand mean is given by you sum the mean per treatment, you divide by the number of treatment. That only works on the balanced, and I will explain why. So this formula that I'm about to write here, it caters both balanced and unbalanced. So the grand mean, as I said, is which is y bar dot dot, it's y dot dot over n. So it's the summation of each sum of each treatment. So sum of treatment number 1 until number of treatment, that's the overall sum divided by n. So these formulas will get it here, because in this case, if you can remember about the mean, it means that this guy y bar I dot is the same as y I dot over, since it's for each it's ri. So that's how it works. It's not n, it's ri, since it's r for each treatment. So the sum of those ri from 1 to t, that's the one that will give you n. So proceeding further, this formula, when you are given these guys here, the mean for the first treatment, second, and the third, you can find grand mean. You multiply R1 with its mean, R2 with its mean, until R2 with its mean, divided by the summation of those R's, R1, R2 until RT. So that's your grand mean. So for balanced Y, when we find the grand mean, we don't have to we don't have to stress ourselves, whereas we're having the means per each treatment. We can take the sum of those means and divide by the number of treatments, because let's just translate it from here or prove it. So this one, if R1, R2 until RT are all equals to R, so we have our grand mean as the summation from I to T instead of RT, where is RI, we write R, so Y I bar dot divided by summation of R. So since this R is a constant, it's the number of replications, so we can take R out. We have the summation from I to T of the mean of each treatment. So the mean of so you know that. So here we divide by T times R, since it's summing to T. So that's why your N under the balance is equals to T times R. Hopefully you understand. So proceeding further, R will cancel out R. That's why we have this, which in your case you can write it as y1 dot bar plus y2 dot bar plus until you write those particular yt dot bar, you divide by the number of treatments. So you see how is this connected. So the thing is that it's all about the matter of understanding. These things they don't require cramming, so learn from me. So I'm not the best, but I think I have tried all my best to make most of you, those whom were lost, to understand what's basically going on in here. So thank you for watching. You all welcome. So we'll do examples next time. I love you, my friends.